Okay, so we are back filling in our notes here. So now we're talking about our formulas, right? Mass percent from our formula. So first off, right, what we're going to need is we're going to start by finding our molar mass. All right, we're going to start by finding our molar mass. So we got to find start from each individual element, add them all up, get a percentage. Okay, so if we have K2CrO4, right, individual element would be K, right? We've got two of them, so we add that together, 78.2, right? If then we get our full formula mass of K2CrO4, all together, that's going to be 194.2. If we just do that, right, 78.2 divided by 194.2, that gives us 40.3%, right? That one's easy. If we then come down here, simplest formula for percent composition, right? First off, right, we have a poem that goes with this. Percent to mass, mass to moles, divide by small, multiply till whole. All right, so percent to mass, mass to moles, divide by small, multiply till whole. Okay, so, oh, I didn't get that on the screen. Let's try that again. There we go. That's a little better. So now we can see it. Okay, so if we have something with, we're going to do an example here, right? So if we have 26.6% K, we're going to have 35.4% of CR, and then 38% O, right? It could be the same thing, K2CrO4, could be something else. I don't know. I have my percentages now. I'm going to try and get to my the formula, okay? So, first off, each of these, we're calling them grams. Okay, so we're going to say this is 26.6 grams of potassium. This is 35.4 grams of chromium and 38.0 grams of oxygen. Percent to mass. Easy, right? Now we're taking our mass to our moles. So, right, grams to moles, right, 1 mole of potassium is 39.1 grams of potassium. 1 mole of chromium is 52 grams. And then 1 mole of oxygen is 16 grams of oxygen. Okay? I'm going to do that conversion. Grams is always going to cancel with grams for each of these, so I made sure that I set it up correctly. I should get moles of potassium up here, moles of chromium there, and moles of oxygen here. Oh, I need to slide it over here. So if I do that first calculation, 26.6 divided by 39.1, I'm going to get 0.68. I'm going to get 0.68 and 2.38. Okay? So I do each of those calculations. Now I go on to my next piece, divide by small. So I'm going to divide by the smallest number. Smallest number is 0.68. So I'm going to divide by 0.68. This is now 1. This is now 1. This is now, 3.5. Right? This is where we need to multiply to a whole. Sometimes, if you've got all whole numbers, it's easy. You don't have to do anything. But I need to multiply to a whole. So to get 3.5 to a whole number, I need to multiply each of these by 2. So I multiply it by 2. I have 2 potassium atoms. Multiply this by 2. I'm going to have 2 chromium atoms. Multiply this one by 2. I'm going to have 7 oxygens. So my formula is going to be K2 Cr2 O7. Right? I've got potassium dichromate. Okay? So we're going to keep on moving down here. If I go ahead, I don't know if I'll have enough space here. We're going to try. We may have to make it work. All right. So, simplest formula from analytical data. This is really going to end up being a very similar thing, but we need to make sure that we know where our elements are going. Okay. So, if I have acetic acid, and say we don't know what that is right away, right? So say I've got acetic acid, we know that it's contains carbon, hydrogen, and oxygen, okay? And this is something that often happens. I'm going to take a gram of it, and I'm just going to burn it in air. So if I burn it in air, right, it's going to be burning in oxygen, okay? So it burns in air, and it's going to give me 1.466 grams of CO2 and 0.6001 grams of H2O. So if you add these two together, right, there's more mass here than there. That other mass has to be coming from the oxygen from the air, okay? But all of our carbon had to end up here. All of our hydrogen from our initial acetic acid had to end up down here. So what I can do is I can figure out how much carbon I had and how much hydrogen I had, and then whatever was left over in our initial 1 gram has to be oxygen. Okay? So my 1.466 grams of CO2, right? I can't just convert grams to grams. I have to go through moles. So my 1.466 grams of CO2, I'm going to convert it to moles. So 1 mole of CO2 is 44 grams. And then I can do my conversion. I know 1 mole of CO2 is 1 mole of carbon, right? When I burned it in air, my 1 carbon atom from whatever amount of acetic acid came over here. It's a 1-to-1 ratio, okay? And then I want to know how many grams of carbon I actually had. So 1 mole of carbon is 12 grams of carbon. If I do that calculation, turns out that I started with 0.400 grams of carbon. Okay? Oh, can't quite see it. There we go. Okay? So now, we're going to come back here. Now I can take my 0.6001 grams of H2O, and we're going to figure out how much hydrogen I started with. So how much hydrogen I started with, right? I can't convert grams directly to grams. I got to go to moles. So 1 mole of H2O is 18 grams. And then I can do my mole-to-mole conversion. 1 mole of hydrogen. Oh, not quite. I have 2 moles of hydrogen in 1 mole of H2O. Right? H2O, we've got 2 hydrogens there, so we get 2 moles of hydrogen in that. And then I come, and now I'm going to convert to grams. My 1 mole of hydrogen is 1 gram of hydrogen. And so when I do that calculation, it turns out that I have 0.067 grams of hydrogen. Okay? So, I know how much carbon I started with, I know how much hydrogen I started with, and I know that I started with 1 gram of my acetic acid, so I can figure out how much oxygen I had. And then I'm going to go through the same steps from the previous previous problem. So 1 gram minus 0.4, whoops, I'm off the screen here again, 400 grams of carbon minus 0.067 grams of hydrogen is going to give me 0.533 grams of oxygen. Okay? So, that's all that we need to do there. Now we have grams for each. So, if we go back to the previous problem and we look at our thing, where are we at? We have masses of each of our components. So, I can take my mass to moles, and then I'll divide by the small, and if I have whole numbers, I'm totally good. Or, if I need to multiply, I can multiply them till I get to a whole number. If I do that, which I think you guys can, I should get to CH2O. Then, we get to do one last step. We can go from our we can get to our molecular formula from the simplest formula, right? The simplest formula, this is just the lowest whole number ratio of atoms, right? That would be our CH2O. But if I know the molecular mass, right? If I know the molar mass, then I can figure out what my actual molecular formula is. So say I know that my acetic acid, I was able to figure out that the molar mass was equal to 60 grams per mole. I can look at my CH2O and say, oh, well, the molar mass of CH2O is equal to 30 grams per mole. And my ratio is my actual molar mass is 60 grams per mole. So the ratio between the two is, right, 60 divided by 30 equals 2. So I need to take each of my components and multiply them by 2. So my actual formula for acetic acid is C2H4O2, right? There's my molecular formula, okay?